Lesson 74, simplifying square roots. So what you see here, the square root symbol, we would call that a radical symbol. And every element or every number inside or variable inside the radical symbol would be called the radicand. So a couple things that we want to look at today. So the property of square roots. The product property of square roots says if you have a radical, such as the square root of a, b, you can break them apart and have that as the square root of a times the square root of b. So you're just really breaking down the factors. Just like you would do a factor tree when you're doing prime factorization, it's the same thing with radicals. So an example here, you have the square root of 12. The square root of 12, I can break that down as a square root of 4 times the square root of 3. Somebody else could have done the square root of 6 times the square root of 2 if you wanted to do that. But the key here is when you're dealing with radicals, you want to try to break it down with at least one perfect square. And the reason why you do a perfect square is because with perfect squares, the root is actually an integer, a whole number. So the square root of 4 is 2. Then all you have left is a square root of 3. I can't break down 3 anymore, so my answer would be 2 times the square root of 3. So you want our answers in radical form. You could easily put that in your calculator and it would give you a long decimal, but they don't want you to have it with the decimals here. They want you to break it down with radicals. So another example here, you have the square root of 600. You can they're breaking it down as with prime numbers. So remember, prime numbers have exactly 2 factors. So usually you have like your 2s, 3s, 5s, 7s. Those are the main ones that you're going to be using. For this one, I would have used a perfect square. If I were doing the square root of 600, I would have done the square root of 600 is the same as the square root of 100 times the square root of 6. And I can break these down further. The square root of 100 is 10. Square root of 6, I can break that down as the square root of 2 times the square root of 3. Since neither of them are perfect squares, I would have an answer of 10 times the square root of 6. I would just combine these two. And you can see this is what they had. But look at all the numbers that they used compared to what I used. Using this perfect square saves a lot more time than if you were just to break it down with prime numbers. Let's take a look at some examples here. Simplify the square root of 216. So let's think. Is there a perfect square that I can take out of 216? Well, here, this is where you can make use of your calculator. So if I did 216, and let's think of my perfect squares. I got 4 as a perfect square. So if I take 216 divided by 4, 216 divided by 4 is 54. So let's just say I did 4. So square root of 4 times the square root of 54, because the 4 times 54 gives me 216. I want to break this square root of 54 is pretty big, so I want to break that down. That could be the square root of 9 times the square root of 6, because I know that 9 times 6 gives me 54. Here I know that square root of 4 is a perfect square. That equals 2. I know the square root of 9 is a perfect square. That equals 3. I cannot break down the square root of 6 any further besides 2 times 3, but that's still going to give me 6. So this remains as a square root of 6. So my answer would be 2 times 3, which is 6, times the square root of 6. Next one, 210. 210. So if I think of some perfect squares, let's try with 4 again. If I do 210 divided by 4, that gives me a decimal. So I know that I don't want to use 4. 210 divided by, the next one would be 9. 9 does not work, that gives me a decimal as well. 210 divided by 16 gives me a decimal. The next perfect square is 25. 210 divided by 25 does not work. 210 divided by 36 does not work. You can see that a perfect square would not work in here. So let's just break this down with factors that we do know. I know that 21, to get 21, that's 7 times 3. So if I do a square root of 70 times the square root of 3, that gives me 210. I can break down 70. See, 70, let's see if there's a perfect square. 70 divided by 4 does not work. 70 divided by 9 does not work. So let's just break this down as the square root of 7 times the square root of 10. Then I can break this down as the square root of 2 times the square root of 5. Since there are no partners, there's no perfect squares, I have my answer, I have a square root of 2 times the square root of 3 times the square root of 5 times the square root of 7. Since there is no partners, there's not a square root of 2, another square root of 2, there's not another square root of 3 or 5 or 7, because they have no partners, the square root of 210 is simplified. That's the smallest radical you can have. If they didn't ask you to simplify that, they asked you for a decimal, then it would be between 14 and 15. But since they're asking you to simplify it with radicals, you have to have radicals, and 210 is the smallest radical. The second problem, instead of walking 200 yards from point A to point B, Arnold takes a shortcut across the field. How long is the shortcut? Now for this one, since we have a right triangle and we're given our legs, we can use the formula a squared plus b squared equals c squared, the Pythagorean theorem. Your two legs are your a's and your b's. We need to find the c. So if a is 100 and b is 100, we need to find out what c squared is. So 100 squared plus 100 squared would give us 20,000. This would equal c squared. Now to undo a square, you need to find the square root. So the square root of c squared is c. Whatever you do on one side, you must do on the other side. So we need to find the square roots of 20,000. And so let's break down 20,000. I know that I can break this down as a square root of 2 times the square root of 10,000. And the reason why I'm breaking it down with 10,000 is when you have a power of 10 or a multiple of 10, if I count how many zeros, I have 4 zeros here. If I split it in half, that gives me 100. So I know the square root of 10,000 is a perfect square. So this would be 100. And then all I have left is the square root of 2. So my answer would be 100 times the square root of 2 yards. Other practice problems. Here, simplify square root of 20. So here I'm going to use the square root of 4 because it's a perfect square times the square root of 5. Square root of 4 is 2. I can't break down 5, so this would be 2 times the square root of 5. Square root of 30. Again, if you can use a perfect square, use a perfect square. This one would be the square root of 2 times the square root of 15. Can't break this, break 15 down as the square root of 3 times the square root of 5. Since I don't have partners, or I don't have a perfect square, this is the simplified form, square root of 30. Square root of 24. I can break this down as a square root of 4, which is a perfect square, times the square root of 6. Square root of 4 is 2 times the square root of 6. Next one, square root of 125. I know that I can break down that with 5 and 25, because 5 times 25 is 125. Square root of 25 is a whole number, or a perfect square, so that's 5. And then I have the square root of 5 left over, so my answer would be 5 times the square root of 25. Next one, square root of 27. Let's think I have perfect square of 9, so square root of 9 times the square root of 3. Square root of 9 is 3, and all I have left is the square root of 3. So this would be the simplified form of the square root of 27. Then the square root of 48, I know that square root of 16 times the square root of 3, because 16 times 3 is 48. Square root of 16 is a perfect square, that's 4, times the square root of 3. So breaking it down with perfect squares makes it a lot easier. Next one, Jenny folded a 10-inch square piece of paper in half diagonally, making a triangle. What is the length of the longest side of the triangle? So if it's a 10-inch square piece, we would have 10 inches here, 10 inches here. We need to find C. So this would be A squared plus B squared equals C squared. So 10 squared plus 10 squared equals C squared. 100 plus 100 is 200 equals C squared. This one's similar to the previous problem we've done. Find the square root of both sides. I can break this down as the square root of 100 and the square root of 2. Square root of 100 is a perfect square, that's 10 times the square root of 2. And this would be inches. And our last set of problems. Simplify these. Square root of 50. Let's just say you didn't know the perfect squares, so I could break this down as the square root of 2 times the square root of 20, 2 times, let's just say you did 5 and 10. So the square root of 5 times the square root of 10. And now I need to break down the square root of 10, which is the square root of 2 times the square root of 5. Because I have a square root of 5 here and a square root of 5 here, when you multiply a square root of 5 times the square root of 5, or a radical by itself, it becomes what's in the inside. So the square root of 5 times the square root of 5 is 25. Square root of 25 is 5. And then all I have left is the square root of 2. So that is another way of doing it. Square root of 90. Here, this would be the square root of 9 times the square root of 10, if you did it that route. 9 is a perfect square, so this is 3. I could break down this as the square root of 2 times the square root of 5, but I don't have any other 2's or 5's, so I just keep it as the square root of 10. And the square root of 1,000, I have 3 zeros here, so that's not an even split. So I can make this as a square root of 100 times the square root of 10, because there's my 3 zeros. Square root of 100 is 10, and all I have left is the square root of 10. Then it says calculate each square root from the left to the nearest tenth. So here is where we're going to use our calculators. Let me get my calculator out here. And so to find the square root of 50, I'm going to hit, on my calculator, I have to hit the second, and then the x squared button. So square root of 50, hit enter, and it tells me 7.07. So approximate value, so to the nearest tenth, so I need to round this 0 to. The 7 tells me to round the 0 up to 1. So we would say 7.1. Then the next one, the square root of 90, gives us 9.48. The 8 tells me to round the 4 up to 5, so we would say about 9.5. Then the square root of 1,000, we did that right here. So let's put that in our calculators. Second, x squared, 1,000. That gives us 31.62. The 2 tells us to keep it at 6, so 31.6. So as our lesson today on simplifying square roots.